Okay, hello there, YouTube, or wherever you're watching this. This is going to be a sort of relatively quick video kind of explaining how to convert a Cr10S Pro 3D printer, pictured here, into a Voron Switchwire 3D printer, pictured here. Um, this is something that if you happen to have an old Cr10S Pro that you got lying around, it's a way to kind of make it into a better, sort of more modernized, somewhat 3D printer without having to buy a new 3D printer and throw this one away or, try and sell it to someone or that sort of thing. Um, so that was sort of the general idea of this. And yeah, with that, I'll very soon kind of um, cut to a series of live streams that I did that I edited together and cut out all the unnecessary stuff. I think it was like 4+ hours of me streaming it, and I cut it down to like a little over 30 minutes, um, to sort of showcase the hardware assembly of it. So I disassembled the entire thing, removed the internals because specifically one thing you need to do is the big difference between this printer and this printer is this printer has the aluminum extrusions completely exposed, which allows you to attach the motor mounts, which this motor is, I believe this one's the X and this one is the Z axis, but that doesn't necessarily matter at this point. And in order to do that for this, you need to basically cut a hole in here because as you can see, there is a aluminum extrusion that you can use. It's just underneath that shell. So I'll showcase that. And yeah, I guess those are the sort of primary things. Main difference between these two is this one is going to have the x-axis controlled by a belt, and this one is and it's going to have the z-axis controlled by two separate stepper motors with lead screws. And the Switchwire has it where um, there's only one motor for the um, x-axis and one motor for the z, and they sort of work in tandem with one another using cables, or yeah, I'll just call them cables, belts, in order to move it up and down or side to side. Um, the one thing, yeah, and the way it's able to get away with using only one motor for the z-axis is partially because of this thing here, which is essentially a I think it's like something you like buy it on Amazon. It's basically designed to be one of those things that you can like clip to your belt and you can like attach your keys to it, and it's got like a pull apart string that like that you can pull on, and it pulls to a certain length. And I think it's primarily as a way to like prevent pickpockets from stealing your keys or just a way to keep your keys on you or not drop them or something. But the idea is it serves as a sort of tension counterweight. So the string goes from here and it loops over here, this pulley, and then it reattaches to here. So that's kind of the main thing you're adding. You're also adding these linear rails right here and right here. Um, the one thing I didn't do is I didn't take the y-axis and really do anything with that. I kind of left it as is. And the reason for that is it's just I didn't feel that that was necessary for now, but it would be, I guess, fairly simple. Um, But regardless, they've got that, and that should be about it. So I will now cut to that sort of series of that edited together video so you guys can see um, sort of the process of putting it together and getting all the mechanical components installed. And I will see you back. This part is going to be focused primarily, probably completely, on just reconstructing the Cr10S Pro that I've almost pretty much deconstructed at this point and made a couple fairly significant modifications to. So you can see here, this is what the Cr10S Pro looks like, um, mostly without internal components or without a frame or anything like that. So this is the shell. We've basically got these things, which are meant to hold stepper motors because of how the motion system works. And so basically these go like that, and they have, and on the other side of here, you've got extrusions that are attached. So they basically just have to attach to the extrusions on the side, and obviously those extrusions are blocked by this, so you've got to cut a hole through it. What I ended up using to do it is a Dremel, and basically we'll move this to the other side real quick. And so this is what I used to do it. Dremel tool. Um, Almost certainly not what it was designed to do, but seems to have worked. It took multiple tries of recharging it and overheating at least a half a dozen times, and also me, at least on this side, missing the spot where you're supposed to drill it, where you're supposed to make that indentation. But it ended up working out, and the tool still works. So those are the two holes on the hole on either side. So one hole here, just ignore this one, that was a mistake. And then one hole on this side. Now is we're going to begin putting it back together. So first part is this, which is on the inside, and these are the sides that you are going to end up attaching those 3D printed pieces to the side, so it's like that, basically. And you can see some of the Dremel marks because I didn't realize that this would just come out, so that's a good thing to note. If you are going to use like a Dremel or something, or maybe you could probably just use a small drill, to be honest, and then just have like some sort of rotary attachment to it. Um, yeah, just make sure you take this out because you could potentially do some serious damage to your tool. Luckily, it didn't happen to me. And oh, and also, um, be sure to use like eye protection and mouth protection, just to make sure you don't get any micro metal shavings in your eye. That would not be good. So, we're going to start by flipping this guy over onto the underside, and gonna put this one. You can tell which side is the bottom because it's got the sticky side because there's like these foam things that are supposed to go on here, and we're gonna put it right in there like that. So now that is in place, and it should hopefully stay in place, because now we're going to bring this around to the other side. Next up, we have got the y-axis. All right. So we've got these two right here. For this, in this case, I just got everything for to just do the X and the Z axis motion system. I'm gonna keep the Y axis motion system as it is. I'm not gonna replace it with linear rails just yet because, at least for my purposes, I don't think that's strictly necessary. So these are the short variant, and this one is the long variant. It's actually these. And you bring it down here. All right, that is looking pretty secure. It is interesting with the with what you have here. You could just remove the shell entirely potentially and try to create something with this as well. Well, like with just these extrusions and this, um, and just completely forego this. But that means you'd have to print a lot more. You'd actually have to print the shell of the Switchwire and all that. So for the purposes of this, it's probably just better to do it this way. One advantage is it would be easier to enclose it, but we can cross that bridge when we get to there if I need to. I mean, you can see from the short I made that I did like a whole custom enclosure thing with it anyway. So, all right, so that is secure. So second order of business is to get these guys on there. So these are the Z-axis extrusions. I don't think, okay, yeah. So this side, two holes here. This side goes on the bottom. I think they go like that because there's a way um, on the original Switch, on the normal, sorry, on the Cr10S Pro, motors are secured like that with onto these. So they're placed like that, like so. So we're just gonna tip this to the side, probably tip it to that side, and we will get both of these installed. So as long as you've got like a semi-flat surface like this. So now we are going to use some of these smaller guys, but I think these are the pretty much the largest screws that you're going to need to disassemble and then reassemble on this guy. Same Allen wrench. You're just going to get down. Let's start. Okay, so now that we've got that secured, we can move on to the next one. Get another one of these. We are going to thread it into this one. Also, part of the reason I gutted as much of the printer as I possibly could was because I knew I was going to have to make those holes in the side, and obviously you don't want, um, you know, electrical components covered in metal shavings. Could be potentially, almost certainly would cause a short of some kind, and potentially maybe set it on fire or something crazy. So, all right, I think that's good enough. Seems pretty secure. So we've got Y's done, Z done, and then we're gonna get the connector, and that would be this guy right here. You can tell because it's got the things on the ends. So this is where the remaining 4 of these small guys come in. Just gonna move that so you can get a better view. I mean, this is pretty intuitive, to be honest, though. So onto the linear rails. So we've got 2 Z-axis linear rails. Obviously, they're a little longer than the ones on the Switchwire, just so you can actually get to the height of this. That's one of the only reasons you'd want to do this sort of conversion in the first place, at least practical reasons anyway. So we've got those, and then we've got this guy for the x-axis. So that's 1. Now, aside from linear rail itself, we have, let me see, 3D printed parts. So we have got these. I believe there's 3 of these. These are meant to keep the linear rails going in the correct angle, and like as perfect of an angle as you can get, parallel to the extrusions. So there's 3 of these, and then one other piece. So that's the bag you get from specifically Bolt Depot, which is the recommended one if you want to self-source these, at least from Voron. So we got that rail, and we need to get a screw in each one of these holes. So I'm going to start by securing this one on the top. You guys won't be able to see it, but we'll start with that one. Yeah, and last one. Okay, that should be lined up just enough to be able to actually start getting these in. Okay, so I'm going to move this over here. I'm going to attach this guy, make sure it's all the way pressed up against this one, and I'm going to start securing these guys in. All right, first one, it is going in, and it has gone in. Okay. Okay, Good enough. And all right, perfect. So we are done with this side. So now with this one, we do actually use both of these. Okay, so now we've got the y-axis bed that needs to go on. This guy, and I'm just gonna do a little bit of tightening on these outer guys. And then like that. And the rest should just kind of, there we go. This goes, oh, sorry about that, shaky cam. Yep, so this goes like that. Get it wrapped around this side. Get it. Okay. So we got it nice and taut. Okay, these guys are all tightened up. That's moving nice and smooth, I'd say. Not any real play. Okay, that is nice and secure. Okay. So the hook is digging into the end just to make sure it is completely secured on there. This is the tensioning, so primarily for the belt, but it also keeps it nice and locked in. All right, so now we're gonna move on to the other side, which should be definitely a little bit, well, I'm not gonna say easier because there's not two holes, but it's gonna be more lined up than the other one. All right, we are good on those. So we've got these guys come in two parts.
Okay, so we got this guy. We've got the M540. These two, we combine them, like so, and then we get one of these shimmerings on, and then we get two halves of the pulley, like that. Focus in, there we go. And then we get another, and then basically, oh, then we get two shimmerings on, like that. Come on, focus, there we go. And then we have two more halves of a pulley, and then we add one final ring on there. And that is our pulley sandwich, if you will. And then we presumably repeat that with both of them. Then we actually attach these two separate pieces together, like, come on, like so. And then this may be on this side or that side. We'll have to see which one.
That one's complete. Get the T-nuts. We're gonna slide them in. There we go. Okay, welcome back. So after that, a couple quick addendums to that. Um, when it comes to 3D printed components for this, like custom components that aren't specifically for the Switchwire, but for this conversion, um, one thing is the back here. So as you can see, the cable chain in the typical Switchwire goes from here, and then it loops around here, and it goes to the, if you're facing it from the front, it goes to the right side of the printer. And then from there, it goes like this, and it goes down. That works fine for the Switchwire because, again, this is all exposed, and you've got an anchor point here for it. When it comes to the Cr10S Pro, you've got, again, this shell that's kind of covering everything. So if you want to attach it this way, you still can, technically. You just need to cut a hole. Well, actually, I'm not even sure if you can do that because I didn't do that, and I'll explain in a sec. But the bed here is on the larger side, and it's also a lot closer to the extrusions. So it's a lot closer to this. Um, and also add on to that, if we remove this, you've got more extrusion kind of coming onto this side. So that means you'd have to put the hole sort of directly underneath this, where all the cables are going to be going, and that uh, that could be a problem. So instead of doing that, what I've basically done is I've taken this and I've moved it over to this side, and I've taken this and I've moved it over to this side. Um, and that is done with some of these printed parts that I sort of custom made. First one is the keybox setup, or the tensioner setup. So basically just mirrored it, and I also removed a good chunk of material to make it basically the same size as the stopper here on this side. And the reason I did that is because the bed for the is, again, because the bed of the Cr10S Pro is a lot larger, and it basically goes all the way up to here. As you can see, the if this bed went all the way up to there, it would collide with that 3D printed part. So basically, I just kind of changed it to be like this one, whereas you can see there's a bit of clearance there. So yeah, so that's one of the primary changes. Because of that, I also mirrored these two parts, which are, one part goes onto here and one part goes onto here, and then they just mirror, right? Because one of them is used for the anchor for the tensioner, and the other one is used as the anchor for the cable chain. And then the final part for this whole sort of apparatus is this part. This part basically goes, it's got these two holes where you can secure it right over here. In this case, it would be right over here. I believe it was on this extrusion right here. And so it goes out like that. And then on the other side, you have the three holes that you can. It is a little bit awkward now in order to get the threaded inserts for the for the what? The threaded inserts for the cable chain in there. But you can do it. It just takes a little bit of finagling to do it. And then once that's done, these match up again with the cable chain here. Right. And so then you imagine the cable chain just going this way, going up, going down, like that. And oh, also there's this part where you have the three holes for the cable chain, except they're just, again, mirrored. Just the holes are mirrored so that you can have the cable chain go this way instead of going this way. So those are the primary reasons. And also I forgot to mention the whole reason for that um, is because this shell has a hole right here. So yeah, that's the main reason. Um, so you're just reversing it. You're not really changing anything other than that. There's also this guide. I didn't print it out and try it. I just mirrored it again. It may still work, but I haven't tested it. Um, and then I also used uh, a beacon 3D printer instead of using the typical Voron um, bed probe. I used a beacon probe, and so I had a custom version of these printed parts that have holes for the beacon to attach to, like right here. And then the beacon, because it's not like the type of cable that can go through here, it has to kind of go out here instead and kind of go up and around like that. And so I also designed a mount for that that you can just um, mount right over here. Um, yeah, so that's just the special use case if you just happen to have a beacon probe and you want to use it. I also 3D printed that. And I think that's pretty much it for those 3D prints. And now we're going to get into the internals. So I have a... All right, so let's move on to the wiring or the rewiring of all of the components. So um, first off, you've got the power supply and you've got the positive V, negative V, and then these two letters and this one symbol. So for the L is basically going to have the red wire, specifically the red wire, and bring up this picture here, that goes from the power switch. So power switch wire goes down to here and just attaches right there. The N is the black and red wire, so that is the wire from the power outlet or the plug that goes down there and again plugs right into there. And then finally you've got the green and the yellow wire, which is the ground, and that goes from here and then it just plugs into here and it's sort of a, I don't know if you'd call it a relay, but it's basically it goes from here to there, and then there's a third one that connects to the power relay, which I will get to in a bit. And then for the positive volt and negative volt, positive volt is the red wires, negative volt is the black wires, positive volt is the signal, negative volt is the, I guess, sort of ground, sort of. Um, and yeah, so this is where you'd plug the, um, well, if you'd want to power your Raspberry Pi from the printer itself, from this power supply, you would plug it into here. Um, one red into the positive, one black into the negative. You would also have the power for the, you'd also have the power for the um, main board plugged into here, red one into here, black one into here, and you would not have the bed plugged into directly into here and into here. And we'll get to that. Um, I'm pretty sure that's about, oh yeah, and you'd also have the system fans. So the cooling fans the, for like the back of the printer right here. And then there's also like one for the main board down there. Um, yeah, that also gets plugged in here. And in the case, yeah, and also in the case of the of this red one, you do also have one that plugs into the relay. We will get to that. So you should have, for positive volt, you should have one big red wire going from here to the relay, one big red wire going from here to the main board, and one big red wire going from here to the Pi if you want to power the Pi from this power supply and not from a separate power outlet. And also one small wire to power the fans. And then for the negative volt, you would only have three. One for the fans, one for the main board, and one for the Pi. So yeah, that's pretty much it when it comes to connecting things into the power supply. We'll move on to the relay and also the main board. So relay, there are these two, it's hard to tell from this picture, but there's this one is labeled L7, this side right here, and this side is labeled T7. And so L7, it takes in the input from the power source. So it takes the input from the power supply. So power supply powers from this side, and then T7 is the output to the device being controlled, which in this case is the print bed. And basically, how this works is the main board itself doesn't have enough power to actually power the print bed at that size, right? So it needs this relay to basically boost the either the voltage or the amperage in order to give the bed enough power to actually fully heat up and warm up. Um, and so you need this in order to do that. So then the output, again, T7, which is this one, plugs into the printer bed. Um, and oh, okay, I'm sorry. So the printer bed black wire does plug into here. It does plug into the negative V. So I was wrong about that. But aside from that, and then you've also got the ground that's plugged into here as well. So then we've got A1 and A2 over here on this side. So A1 is the positive, so that would be the red wire, and A2 is the negative, that would be the black wire. And yes, okay. So now we move on to the main board. The one I decided to go with was a Big Tree Tech one. I think it's the version 3 point either 1 or 2. I'll probably put that in the description. But regardless, when it comes to wiring, I would recommend always using more wire than you think you need, especially because, again, you will need significantly more wire because it's not like it's going to be a straight from here to here to here. It's from here to here to here to here, right? So um, just kind of measure it out, measure out the length of these, and of this, and then the distance to there, and then just kind of add a little bit to be generous, then just test one wire to make sure it's long enough, and then you can copy that length for all the other wires. Um, yeah. So when it comes to connections here, so this is the input power from the power supply. So if we're facing it from this side, which I guess this is technically the bottom, like it's technically flipped from this perspective, but this is probably the perspective that you'll be seeing it at if you're doing this on the printer. So top here is the negative, so that's the black. Bottom is the positive, the red. Here, the left is the red, and the right is the black, and this is what plugs into the relay. Here is the heating element for the hot end. As far as I can tell, it doesn't matter which order you put these in. Um, it doesn't necessarily care. Um, I mean, maybe it does. Like, if it did care, then why would they have them, the be the same, um, the same color? Then we've got the two fans, so the hot end fan and the cooling fan. For both of them, you've got the black on the left side, red on the right side, and then you've got the um, X-axis limit switch. Now, with self-sourcing the Voron parts, and you will need to self-source the individual Voron switchwire parts, right, in order to do this. You will, from that list, you will get a limit switch that doesn't have any wires attached to it. It's like just three um, like pieces of metal sticking out that you can then like solder a wire onto. So you've got at the top, or you basically have, and then in that limit switch, you can faintly see letters symbolizing each of the three, like metal probes, I guess you could call them. So one of them is labeled C for ground, and the other one is labeled NC for the signal. And so NC would be red wire, or in this case, it would be the white wire, and C would be the black wire, or in this case, the yellow wire. The only reason I changed it up is because I didn't know if I was going to run out of red or black wire, so I just wanted to be kind of conservative with that. Um, and then you've got the y-axis limit switch, which again didn't change the y-axis, so it I reused the cable for that. Moving on with um, these two blue wires. This is the thermistor for the hot end. Um, oh, and these two white wires over here are the thermistor for the print bed, which again, you can reuse that. Thermistor for the hot end. Um, Again, the hot end thermistor that I used just had two blue wires, and when I rewired it, it was fine, like it worked. Um, I would advise maybe having at least um, one crimp, one like break in the wires, like crimp in a break where you can like unplug it and then flip it around just in case. Which I did do for one of these, just to make sure that you don't have to like remove remove like the piece where this plugs in to the main board and try and do that, because that's kind of a hassle. So yeah, that is another thing. You will have to like crimp a lot of new connections here. That's just part of the process. I'll probably like link a kit somewhere that you can use. Um, but yeah, as far as that goes, is that, yes, this. Okay. So this is for the light. that this big tree tech uses for the um, RGB lighting element that you can attach to the switch wire around the hot end area. It basically just gives you a light, and and the one I got, you can change the color to whatever you want and the brightness and that whole thing. So it's just kind of a way to give better flexibility or visibility. Um, and that's about it. It's not required, but specifically for this one, I actually messed this one up. So from facing the board this way, the order is actually red, blue, black instead of black, blue, red. So just flip this around. If you do have it in this incorrect order, the printer will not boot up because it'll get confused. So just do that. And again, if you have like a crimped part somewhere in between, you can just flop that around. That's what I did for this one. Moving on, we've got the motors. Again, these are all pretty much the same. I didn't have to like create new wires for these. So like one of these is like the x-axis, one of these is like one of the z-axis motors, and then the other one is the y-axis. Uh, then we've got the extruder motor, and that one is four colors. The order, I believe, is I'm pretty sure it's green, turquoise. No, sorry, red, turquoise, black, and then blue. It looks like. Um, this is one of those things where you basically copy the wires from the motor itself, and if it starts with red, like this is the same order for the motor itself. So if it starts with red, then you'll know which way to flip it. Um, yeah. So that's about that for pretty much all of the mainboard plugins. We've got we've also got this for the Raspberry Pi, and also this, which is a voltage regulator, which you will need to power the Raspberry Pi. Um, and then the fan that I just kind of double-sided taped on here. Um, and speaking of stuff in 3D prints, so we'll go back to here and have a look at this. So this was meant to be a sort of interface for the main board. So all of these holes right here, these five, are for the main board, and they're designed so on the bottom you can get you can take what a threaded insert and put them in here from this side, and then you can screw them in. And then these are interesting. So on the Cr10S Pro, and I don't know if this model has it. Yeah, I don't think it does, but basically you've got um, you've got these pegs that stick up from the bottom that are used to attach the Cr10S Pro main board, and obviously those don't match up with this, so you've got to create an interface between the two. This was one that I came up with. Unfortunately, I will say, if you are doing this and you've got a slightly different version of the Cr10S Pro, the one I've got is the V1, there's the V2, there's also different versions of the V1 because the relay, if you can see from this picture, is actually on what looks to be a heat sink, is attached to a heat sink. The reason for that is because the original, like when the Cr10S Pro first shipped out, people were complaining about the relay overheating because it didn't have direct contact with like any metal components. Like it had some, I think it was like had a plastic piece interface between it, and so that wasn't conductive at all, and that was causing heat to build up in it. So they fixed it by putting a heat sink in between. So again, it's probably a different version that has slightly different placement of those like peg holes, and you can see the peg holes here for another component. I think that was like the speakers or something. So yeah, there's a good chance that the specific model that I have will not work for you. So you may need to do a little bit of editing around, and also I needed to do some post processing on it. Like I had to let's see, where is the, oh yeah. Like I had to kind of remove some material here because this wasn't completely lining up, and you can't see it from this side, but I had to remove material off of the other side because there was one of these things that was in the way. So it's not a 100% clean thing, but it works fine. So if it works, it works. Um, yeah, okay. So moving on, we have the Raspberry Pi. Now, for this one, the Raspberry Pi, I created this piece where it attaches from the extrusion. And I mean, in theory, you could kind of try, like, it makes a lot more sense for the Raspberry Pi. So it attaches from the top here, and in order to make it more secure, bring you down to the model itself, it has this notch that kind of fits in to the extrusion from the side. So that kind of gives it the ability to like be more rigid and more secure as far as that goes. So second thing of note, you've also got the power cable coming in here. You've got the beacon, and then you've got this third blue cable, which is attached to the main board so they can communicate. And then you've got this for the screen. Um, Now, this cable is one I bought independently of the screen. The screen itself is a Big Tree Tech Pi TFT43 version 2.1, and it comes with this cable. Obviously, this cable isn't long enough, but like you could, in theory, kind of make it work if you like flipped the Pi around. But the problem with that is that then you have to find, um, like the beacon cable would be fine, but the cable going into the main board isn't, you know, really long enough for that. So you'd have to buy a different one of those cables. So I guess it's kind of up to you on which one. Although even then, if you flip that around, that may not even be enough even then. Um, so yeah, it depends. But crucial thing is this cable. It needs to be, let's see, we can count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Yeah. So it's 15 lanes. It has to be 15 lanes, and it has to be, um, you've got to have a open connection on one side, and then you've got to have like I guess a quote unquote closed connection on the other side. So basically, it's you don't want to have it where you've got exposed copper on this side and on this side, because if you do have that, then it's not going to work. So if you're buying one of these like ribbon cables to get it to work, it needs to have exposed copper on this side and then exposed copper on the opposite side. If you flip this over, then this side would have it exposed. Um, so yeah, hope that makes sense. Very important, so you don't, like I did, kind of waste money on an unnecessary cable. So then we'll move on to the voltage regulator for the Pi. So this is kind of a close-up from one of the live streams that I didn't bother putting in this because it was just so much happened after that it just wouldn't make sense in terms of wiring and all that. So how this works is you've got the input, so the in plus and the in minus from the power supply. I used larger wires in the final thing, and you will need to like crimp attachments for that, and then plug those in to the um, or screw those in or whatever you want to call it to the power supply, the positive and the negative, and those two go in the in, and then the two outputs. For that, you need to sacrifice a some USB-C cable. Just snip it, and then you'll have those two wires, the red and the black. Um, and you'll need to like solder other wires to them, and then solder those to here. And then once you do that, you've got this little screw, I guess you could call it, and you'll need a small screwdriver. And what you want to do is you want to get a voltmeter and put the voltmeter on the out plus and the out minus, and then you set it to like, I think it's, you're measuring for volts um, for, I think it's like 60. Yeah, you set it to like 60. And then what you want to do is you want to reduce the voltage because the power supply delivers 24 volts if you don't regulate it, and that will completely destroy, like that'll fry the Raspberry Pi. So you don't want to do that. Um, I'm pretty sure, I don't remember exactly, but I'm pretty sure it was 5 volts. That the Raspberry Pi takes like 5 volts. So you want to regulate it down to 5. Double check that just to make sure, but you want to regulate it down to about 5, and you don't want to go above like 5.1. You might want to go a tiny, tiny bit above 5 if you think there might be a little bit of power loss in order to prevent the Pi from being underpowered and potentially shutting off on you. But the important thing is you need to downgrade it to about 5 volts in order to prevent the Pi from exploding. So that's the important part there. Again, if you want to do this, you do not have to do this. You can just power the Pi with just a normal power supply that's just plugged into a wall. But if you do want to do it, you can do it. And then finally, when it comes to the Clipper screen itself, this was the tutorial that I followed this video. Um, and he has 3D printed parts specifically for it, and I used the 3D printed parts to attach the screen. Um, when it comes to the screen itself, it does use, I think it's like M dot, like M, it doesn't use M3 screws and it doesn't use M2 screws. I think it's like M2.5 or something kind of weird. So that could be um, a slight issue if you don't have any of like those screws lying around. I had like at least two small ones lying around, so I could use them and attach it. But then the other four just attaching the whole thing to the printer, those are just M3s, so that shouldn't be an issue. But yeah, I think that's about it. Oh yeah, when it came to the screen, if you do plug it in and it just has a backlight, like the backlight comes on, but it doesn't display any images, any visuals at all, and you make sure it's like in, and you go into the settings, like you remote into it while it's plugged into the Pi, and you make sure that it's set to like the correct screen or to the correct like driver that it's using, then the odds are pretty good that it's broken. I say that because that's what happened to me, and I was kind of going back and forth with Big Tree Tech for like over a week on it. Finally sent them a detailed video showing what was going on, and they eventually did send me a replacement that worked immediately out of the box. So just something to be wary of. But yeah, I think as far as that goes, um, I mean, that's kind of about it. Okay, so one more thing when it comes to converting the two, and just is the setup. So setting up the printer on Clipper is going to be pretty much the same way. Um, this is the printer.cfg file that I have come up with so far, right? So for you can just kind of look at these printer settings, MCU. The serial port is probably going to be different, and you're going to have to figure that out for yourself. Let's see here. So rotation distance, this is important for the, yeah, I mean, wait a minute. No, that's the X stepper, so that's fine. Um, okay. Position minimum and position maximum. These two are important. Um, so the so when it comes to the really quick, so right here, you can see the limit switch is attached to the gantry sort of assembly, the hot end, right? And it bumps into this side. So it's going to go to, in order to home, it is going to go to the right instead of the left, unlike the Cr10S Pro, which goes left instead of right. So that being said, the coordinates are still going to be the same, where this is going to be x0 and this is going to be x however big it is. So because of that, the position minimum for me was -35 and max was 310. So the max should be the maximum length of the build plate. And then homing speed, you can keep it for that. Stepper Y, again, similar sort of thing where you've got the position minimum as 0 and the position maximum of 315. At least that's what I put. You, in order to do this, you do actually need to make sure that the Y limit switch is in the correct spot, because this one is attached to the printer. And so what you want to do is you basically want to go over here and you want to move the bed um, this way and move it out to its as far as it can go, essentially. I'll just disable that magnet. Go out to as far as it can go. Okay, actually, sorry. You do it this side. You do it this side. You do it to as far as it can go here without like running into this, and you set the limit switch to there. So you basically um, you bring it to there because now the position end stop and the position minimum are the same. Those have to be the same, and this does have to be the length of the build plate. Like, these have to be 0. If it's not, that can cause sort of weird issues of it like printing not in the center of the bed when it should be printing in the center of the bed. And that was kind of a weird sort of thing I had to figure out. The other thing is the homing positive direction. This is important because this was originally switched to true, and when it was, I was printing mirrored, essentially. So it would home just fine, um, but when I set it to go to like 0, 0, instead of going to here, it would go to here as 0, 0. And when you do that, and when you try to print something, then that'll basically cause it to be mirrored, um, which is obviously not what you want. So that's a very important setting to check. Um, if you are having like the coordinate 0, 0 being this, you've got to switch that from true to false. Next up, you can just kind of ignore that. Z-stepper, again, this is, I put it at 300 for now, and the pin is going to be the Z probe, assuming you're using the Z probe or you're using, um, you could, I don't know how difficult it would be to like use, I mean, it comes with a BL Touch, right? Basically the Cr10S Pro V2. So I'm sure there's some mount that you could find for the Voron hot end where you could just attach that, but you'd set it as that. Moving on, we've got the extruder. Okay, so the rotation distance for the extruder is important. You've got to figure out that with a E-steps calibration. You can look up how to do that. It's not particularly difficult. You basically just extrude a certain amount, um, slowly see how much actually gets extruded compared to the amount that you wanted it to extrude. If it's off, you use that difference to determine what the new rotation distance should be, and you test it again to confirm. Relatively simple. Next up, we've we can keep all of that. Okay, heated bed. Okay, the probe. So this is something for the beacon specifically. Um, you'd have this specific beacon one. You determine what the serial is, determine what the offset is. I put the Y offset at -30 based off of the mount that I'm using. That's hopefully correct. Haven't done in-depth testing to make sure, but it homes in the center and it sort of, um, yeah. Anyway, not super relevant. Fans, the Z home. Okay, so the Z home position should be half of the bed, the total bed size. So I said that the bed was 310 on the X and 315 on the Y, so this is just half of that when it's homing. Bed mesh, this obviously depends on the probe that you're using, but I put the max at the min at 15.5 and 290/280. When it comes to the probe, it will not go all the way on the y-axis. I believe on like here, just because the bed just can't go like that far without running into the end. So it does have a couple limitations in that regard, but it's not a super huge deal. Okay. Displays. For me, the I just needed to install clipper screen on that screen when you plug it in, and it worked fine for the touchscreen. Like touchscreen capability worked, it worked all just fine. So that was my experience. Um, okay, lights. So lights on and lights off. You set those G-code values. So this is what you want to do if you got the NeoPixel that I got, which is like the three separate LEDs that's like specific for the Voron. Again, I'll kind of link that, but you want to have the pin be this, at least for the Big Tree Tech board. Chain count, 3 of them, and then you could probably set to whatever you want for these. I don't think it's super big deal, but that's the color order. And then macros, didn't really change anything about any of this. And yeah, I think that is about it. So you've got, you know, if you're, um, yeah, if you're converting this, it's definitely something I wouldn't recommend just like buying a Cr10S Pro to specifically for the purpose of converting it to a Switchwire. That kind of seems a bit wasteful. If you were to go on to eBay, right, like you can get them for 250 used. Like the ultimate deal would be to get them for like just for parts for like $100 or something. Um, or you could potentially find something with neat upgrades or something like that. But in the grand scheme of things, it's it's probably not worth it. So I would say you would probably want to do this if you had a CR10S Pro and you didn't want to like give it away or try to sell it because like you didn't want to go through that hassle. I think this is kind of a good way um, to sort of repurpose it and make it a little bit more modernized, right? Um, Let me think if there's anything else. Yeah, if you did want to like convert a different printer to a Switchwire and like buy it, um, there's with a similar build volume, there's the Cr10 and the Cr10S, just the non-pro, that would definitely be a better choice because they do have the exposed metal extrusions, so you don't have to worry about cutting holes and all that stuff. And it would also be a lot easier to do the enclosure, which I didn't mention that, but the Switchwire does have an enclosure that you can use for it, which could be pretty useful. And again, with this, it's like even if you were to just do it without the shell, you just don't have near the amount that you would need in order to do that. So that's what I'd recommend. There's also the Ender 3 if you want like a smaller build volume. There are videos on that. Um, but oh yeah, there's one final thing. I have not done it yet, but when it comes to this extrusion and using this one. So as you can see, this extrusion is a bit longer, not only just longer than this one in general, but longer in relation to these extrusions. So as you can see, this one comes up to, you know, it's like right past the sort of notch part. Meanwhile, on this one goes way beyond. And that isn't necessarily a problem for me yet, but basically you can see how the belts work. And so you've got this one belt that goes here because of how this is, that belt is kind of more going like that, right? It's got a bend in it. I don't know how much that can impact things, and it hasn't like gotten caught on here yet, but that could potentially possibly be an issue. Um, so a way to fix that, easiest way, would be to just cut a little bit off of it. That would, in this case, at least on this side, it probably wouldn't. Yeah, I mean, that would probably prevent you from, if you were to cut it, that would prevent you from going back, right? Because all of the changes made up until this point, you could still technically just go back to the original, but then again, why would you want to go back to the original is kind of the whole point. Um, so if you're fine with cutting off of it, or you could just buy another extrusion and cut that down to the right size. Um, so I might experiment with that in the near future. Test that. The one thing though is, again, the difference in the distance between here and here, like the bed and the extrusion versus here and here, does mean that this print head might not be able to go all the way out to here because of that. So it might slightly limit the build volume a little bit. Um, and again, I haven't tested it, but it's a very possible. And the only way I could think of getting around that is if you were instead to just redesign this whole thing where you had this and then you redesigned it to have this kind of go out more and then have this one kind of go out more. Um, but yeah, for most people, it would probably just make more sense to just cut this down. But yeah, I think that's about it. Um, Hopefully, this was a decent sort of guide. Um, I kind of saw a couple sort of disparate posts about this conversion around, and there was one guy who did a live stream series on it, but he never seemed to finish it, or at least he never recorded himself finishing it. So I guess that's something I kind of wanted to do, to kind of just sort of complete that and make it like comprehensive of like a step-by-step guide. Um, but yeah, I mean, if you print out the Voron documentation for the assembly, steps are pretty much the same, you know, with just a couple minor differences. Um, yeah, I guess that's about it. Um, and I will see you potentially in another video, maybe a different conversion. I've got a Mono Price Select Mini, a version 1 that I've been thinking about potentially doing something with, but it's a little bit more constrained as to what you can do with something like that without just completely just tearing it apart and like reusing basically nothing from it. So we will see, but that might be an interesting thing. But yeah, I guess that's about it. I'll have, by the time this video goes up, I'll probably have a like a printables or a Thingiverse page for these models. Um, and yeah, and maybe like a GitHub or something. But that's about it. Um, See you later. Maybe. We'll see.